A pleasant day to everyone, and welcome to our presentation on the derivatives of logarithmic functions. Together with my group mates Viana Lee Adwincula, Cyrella Cambra, Archibald Lunar, Tricia Lee Hitimas, and Ace Clarence Yu, we will be exploring the derivative of the different logarithmic equations.
Okay, so for number 1, we have the equation y is equal to the logarithm of quantity x minus 1 raised to 3 times quantity x plus 2 raised to 2. So, first, we have to use the logarithm property wherein yung log ng product ay equals sa sum ng logs. Kaya yung function natin ay magiging y is equal to logarithm of quantity x minus 1 raised to 3 plus logarithm of quantity x plus 2 raised to 2. And then, pwede siyang, yung mga exponents, pwede siyang dalhin sa harap gamit yung power rule ng logarithms. Kaya magiging 3 logarithm of quantity x minus 1 plus 2 logarithm of x plus 2. Ngayon, pwede na siyang i-differentiate. Kaya magiging 3 times 1 over x minus 1 plus 2 times 1 over x plus 2. And then, yung magiging derivative na natin ito kapag pinag-times siya ay dy dx is 3 over x minus 1 plus 2 over x plus 2. Yun yung final answer. So, for number 2 naman, we have the equation y is equal to natural logarithm of quantity x plus 3 raised to 4. So, katulad nung number 1, pwede ulit natin i-bring down yung exponent or ilagay sa harap. Kaya magiging y is equal to 4 natural logarithm of quantity x plus 3. And then, kapag dinifferentiate siya, i-keep lang natin yung 4 sa harap. Kaya magiging 4 times, tas yung differentiation ng x plus 3 ay 1 over x plus 3. Kaya kapag pinag-multiply yun, yung magiging final answer natin or yung dy dx ay 4 over x plus 3. Next, for number 3, we have the equation y is equal to the natural logarithm of quantity x plus square root of x squared plus 1. So, pwede natin substitute yung u or yung nasa loob ng parenthesis, which is yung x plus square root of x squared plus 1 by the chain rule. Kaya yung dy dx natin ay magiging 1 over u times du over dx. So, first of all, iti-differentiate muna natin yung u or yung nasa loob ng parenthesis. Kaya yung x plus square root of x squared plus 1 ay magiging 1 plus 1 over 2 square root of x squared plus 1 times 2x. So, makakancel lang dito yung 2 na nasa fraction, pati yung nasa dulo na may kasamang x, and mamumultiply lang siya doon sa taas. Kaya yung magiging answer or yung differentiation ng u ay 1 plus x over square root of x squared plus 1. And then, isa-substitute lang natin to pabalik sa dy dx. Kaya magiging 1 plus x over square root of x squared plus 1 all over x plus square root of x squared plus 1. And then, pwede na natin mas-simplify yung numerator niya. Kaya magiging square root of x squared plus 1 plus x all over x squared plus 1 na naka-square root. And then, kapag inayos na natin siya sa fraction, marami siyang magiging same na form, same na numbers, or ayun, same yung form nila. Kaya pwede siya ma-cancel out. Kaya maka-cancel out yung square root of x squared plus 1, pati yung x sa numerator and sa denominator. Kaya yung malilive or yung matitira na lang sa dy dx natin ay 1 over square root of x squared plus 1. Okay, so for number 4, we have the equation y is equal to the natural logarithm of quantity 1 minus sine x over 1 plus sine x raised to 3. So, ayun, pwede ulit natin ibaba yung exponent niya sa harap or ilalagay natin siya sa harap, diba? Kaya, magiging 3 natural logarithm of quantity 1 minus sine x over 1 plus sine x na siya. And then, gagamitan lang natin siya ng chain rule. Kaya yung dy dx natin, matitira lang yung 3 sa harap, times 1 over 1 minus sin x over 1 plus sin x times 1 minus sin x over 1 plus sin x. And then, pwede na natin siyang gamitan ng quotient rule kasi yung fraction, yun yung i-differentiate natin. Kaya, pwede natin gawin na yung u natin is yung 1 minus sin x and then yung v natin is yung 1 plus sin x naman. Kaya, using the formula ng quotient rule, low d high minus high d low all over low squared. Kaya, kapag sinubstitute natin yung values dun, magiging quantity 1 plus sin x times quantity negative cos sin x minus 1 minus sin x times cosine x all over 1 plus sin x squared. Kaya kapag distribute lang natin yung mga signs, yung magiging final answer ng differentiation ng fraction ay negative 2 cosine x all over 1 plus sin x squared. Next naman, pwede na natin i-multiply yung outside term. And kapag nagmo-multiply ay kinukuha lang yung reciprocal ng fraction. Kaya, yung dy dx natin, again, retain lang yung 3. And then yung reciprocal, 1 plus sin x over 1 minus sin x times yung nakuha nating differentiation ng fraction gamit yung quotient rule, which is yung negative 2 cosine x over 1 plus sin x squared. And then, yung magiging answer nito ay 3 times negative 2 cosine x over 1 minus sin x times 1 plus sin x. And then, pwede na natin dito masimplify yung denominator. Kaya magiging 1 minus sin squared x siya, which is equal to cos sin squared x din. Kaya yung derivative natin ay magiging 3 times negative 2 cosine x over cos sin squared x. Kaya kapag times to, magiging negative 6 over cosine x dahil makakancel yung cosine x sa taas and then matitira yung isang cosine x sa baba. So, pwede siya kapag yung derivative, pwede pa siyang maging second. Kaya yung magiging final answer natin ay dy dx is equal to negative 6 secant x.
For number 5, we have the equation y is equals to the natural logarithm of secant x plus tangent x. So we have the argument u is equals to secant x plus tangent x, and we are going to get its derivative or the u prime, which is equals to secant x tangent x plus secant squared x. And after that, we are going to put it in the derivative formula of a natural logarithm, which is equals to 1 over u times the derivative of u with respect to x. So we are going to have 1 over secant x plus tangent x multiplied by secant x tangent x plus secant squared x. So when we combine it, we'll have secant x tangent x plus secant squared x over secant x plus tangent x. And after that, we are going to factor out the common term on the numerator, which is secant x, and we'll have secant x outside the parentheses because it is factored out, multiplied by the quantity tangent x plus secant x over secant x plus tangent x, and this will lead to the cancellation of tangent x plus secant x on the numerator and the denominator, and will arrive to the derivative of the equation, which is secant x. So for number 6, we have the equation y is equals to the natural logarithm of x squared multiplied by the quantity x plus 1 divided by x minus 4 raised to 3. So first, we are going to apply the quotient rule. So we'll change the division into subtraction. So we'll have y is equals to the natural logarithm of x squared multiplied by the quantity x plus 1 minus, since we apply quotient rule, minus ln x minus 4 raised to 3. Next, we are going to apply the product rule. So we're going to change multiplication into addition. So we'll have y is equals to the natural logarithm of x squared plus the natural logarithm of x plus 1 minus the natural logarithm of x minus 4 raised to 3. So now we are going to apply the power rule, which is will bring down the power and we'll put it in the front. So we'll have y is equals to 2 times the natural logarithm of x plus the natural logarithm of x plus 1 minus 3 times the natural logarithm of x minus 4. So now that it is simplified, we can now get the derivative of each term separately. So we are going to apply the formula for the natural logarithm, which is 1 over u multiplied by the derivative of u with respect to x. So we'll have 2 multiplied by the quantity 1 over x times 1 plus 1 over x plus 1 times 1 minus 3 times the quantity 1 minus x minus 4 times 1. And when we simplify it, we'll have 2 over x plus 1 over x plus 1 minus 3 over x minus 4 as the final answer. Moving on to the next number, number 7, we have the equation y is equals to the natural logarithm of the natural logarithm of 4x. So we have the argument, the natural logarithm of 4x, and the derivative of the argument is equals to 1 over 4x times 4. And when we combine it, we'll have 4 over 4x, and cancelling out the 4 on the numerator and the denominator, we'll have the derivative of the argument is equals to 1 over x. So now, we'll get the derivative of the equation. We'll have y prime is equals to 1 over the natural logarithm of 4x multiplied by 1 over x. This will be equals to 1 over x over the natural logarithm of 4x, and when we simplify it, we can bring down the x on the numerator and put it on the denominator since it is in the fraction form. So we'll have the final answer, y prime is equals to 1 over x times the natural logarithm of 4x. Moving on to the next number, number 8, we have the natural logarithm of xy squared is equals to xy, and we can apply here the implicit differentiation, but first we're going to simplify the equation by applying the properties of logarithm, which is the product and power rule. So when we simplify it, we'll have the natural logarithm of x plus 2 times the natural logarithm of y is equals to xy. So now we can proceed to the differentiation of the equation. For the left side, we can apply the derivative of a natural logarithm by applying the formula 1 over u times the derivative of u with respect to x. So we'll have 1 over x times 1 plus 2 times 1 over y times y prime. And for the right side, we can apply the product rule of the derivative, so we'll have xy prime plus y times 1. And when we simplify it, we'll have 1 over x plus 2y prime over y is equals to xy prime plus y. Next is we're going to isolate the terms with y prime, so we'll have 2y prime over y minus xy prime is equals to y minus 1 over x, and we'll factor out the y prime, so we'll have y prime times the quantity 2 over y minus x is equals to y minus 1 over x. And when we combine the fractions, we'll have y prime times 2 minus xy over y is equals to xy minus 1 over x. And we're going to divide both sides by the quantity 2 minus xy over y, so we'll be left with y prime on the left side. This will be equals to y prime is equals to xy minus 1 over x divided by 2 minus xy over y. And to simplify it, we're going to get the reciprocal of the the denominator, and multiply it with the numerator. So we'll have xy minus 1 over x times y over 2 minus xy. And when we multiply it, we'll have xy squared minus y over 2x minus x squared y. And we can see that we can factor out the common terms, y for the numerator and x for the denominator. So we'll have the final answer, y times the quantity x minus y minus 1 divided by x times the quantity 2 minus x times y.
For number 9, x ln y plus y ln x equals 1. So this problem we need to equals to 0 to find the proper answer. So equals ln y plus y prime over y plus y prime ln x plus y over x equals to 0. So it is equals to 0. So we have go to derivative of each given. So y prime equals x over y plus ln x, and y prime is equals to negative ln y minus y over x. So the answer is y prime equals negative ln y minus y over x over x plus x over y plus ln x. For number 10, y equals 2x plus 1 raised to 2/3 and 3x minus 4 raised to 1/2. So this given, we need to use the logarithmic formula, and we need to write ln or log, etc. So 2 over 3 2/3 ln times 2x plus 1 plus 1/2 ln times 3x plus 3x minus 4. So Next, we need derivative of the parenthesis. So yung kinalabasan 2 over 3 times 2 over 2x plus 1. Bakit 2x plus 1? Kasi kinapi mo sa baba, ilalagay mo yung original, then sa taas yung parang derivative niya. Then plus 1/2 times 3 over 3x minus 4. And next, we need to times the two given. And the answer is 4 over 3 times 2x plus 1 plus 3 over 2 times 3x minus 4. So the original answer is y prime equals 2x plus 1 raised to 2/3 3x minus 4 raised to 1/2 times 4 over 3 times 2x plus 1 plus 3 over 2 times 3x minus 4. For the number 11, y equals third square root of 4x minus 1 times x plus 2 over x minus 5 raised to 3. So this given, we need to change the square root to the exponent of the given. So y equals parenthesis 4x minus 1 times 4x plus 2 over x minus 5 raised to 3 raised to 1/3. So why 1/3? Because the given in first is third square root, so we need to 1/3 of the square root. So next, ln y equals 1/3 ln times 4x plus 1 minus 1 plus 1/3 ln times x plus 2 minus ln times x minus 5. So next, y prime over y equals 1 over 3 times 4 over x minus 1 plus 1 over 3 times 1 over x plus 2 minus 1 over x minus 5. So this is same as the number 10, and we need to times each given. So the answer is y prime equals y times 4 over 3 times 4x minus 1 plus 1 over 3 times x plus 2 minus 1 over x minus 5. So this is the final answer.
For number 12, we're asked to find the dy dx or dy prime given y is equals to x raised to sine of x. First, we'll utilize the logarithmic differentiation. Our equation will become ln of y is equals to sine x ln of x. Then implicit differentiation, we will get the derivative of both sides. Derivative of ln of y is 1 over y times derivative of y is y prime. On the right side naman, we will use the product rule. Okay. Derivative of sine x is cosine x times ln of x plus sine x times the derivative of ln of x, which is the 1 over x times the derivative of x is 1. Then simplify lang, 1 over y times y prime will become y prime over y is equals to cosine x times ln of x plus sine x over x. Then now we can multiply both side by y so that makancel natin yung y dito sa denominator sa left side, and matira na lang is y prime. And y prime is equals to y times cosine x ln of x plus sine x over x. Then we will substitute the value of y, which is the given x raised to sine of x. Now the final answer will be y prime is equals to x raised to sine of x times cosine x ln of x plus sine x over x. For number 13, we're also asked to find the dy dx or dy prime. Given y is equals to x raised to ln of x. Then power rule, we'll just put the ln of x on the left side of x and proceed to logarithmic differentiation. Our equation will now become ln of x times ln of x, and we can simplify this into ln of x squared. And then power rule, then we will put the squared into left side of ln of x, and our equation will now become ln of y is equals to 2 times ln of x. And then implicit differentiation, we will get the derivative of both sides. Ln of x, derivative of ln of y is equals to 1 over y times the derivative of y is y prime is equals to, on the right side naman, 2 times ln of x times the derivative of ln of x is 1 over x times the derivative of x is 1. And then simplify, 1 over 1 times y prime is equals to y prime over y is equals to the right side 2 times ln of x times 1 is equals to 2 ln of x over x. Then now we can multiply both sides by y so that makancel natin yung denominator y on the left side, and now it will become y prime is equals to y times 2 ln of x over x. And then substitute the value of y, which is the x raised to ln of x. The final answer will become y prime is equals to x raised to ln of x times 2 ln of x over x. For number 14, given is y is equals to x raised to x squared. Then power rule on logarithmic, we will just put the x squared on the left side of ln of x. And then utilizing the logarithmic differentiation, the equation will now become ln of y is equals to x squared times ln of x. And then proceed to implicit differentiation, we will get the derivative of both sides. The derivative of ln of y is 1 over y times the derivative of y is y prime. Then sa right side, we will use the product rule. Derivative of derivative of x squared is 2x times ln of x plus x squared. Derivative of ln of x is 1 over x times the derivative of x is 1. Then simplify lang, 1 over y times y prime is equals to y prime over y. Then sa right side, 2x ln of x plus 2x squared plus, times 1 is equals to x squared over x. Then we can cancel the denominator x, power rule. The equation will now become y prime over y is equals to 2x ln of x plus x. Then we can see here that we can factor out the x into 2x ln of x plus x. Then the equation will now become y prime over y is equals to x quantity 2 ln of x plus 1. Then we can now multiply both sides by y so that makancel natin yung y sa left side and matira na lang is dy prime. Then final equation is equals to y prime is equal to y times x times quantity 2 ln of x plus 1. And then we can substitute the value of y. The final answer will become y prime is equals to x raised to x squared times x times quantity 2 ln of x plus 1. And then exponential rule, pag meron tayong x times x, we can add the exponent of the base. So the other answer is x raised to x squared plus 1 times quantity 2 ln of x plus 1. For number 15, given y is equals to ln of x raised to x. And then, power rule in logarithmic, we will just put the x on the left side of ln of x. And then, logarithmic differentiation, the equation will now become ln of y is equals to x times ln of x. And then, proceed to implicit differentiation, we will get the derivative of both sides. Derivative of ln of y is equals to 1 over y times the derivative of y is y prime. And in the right side, we will use the product rule. Derivative of x is 1 times ln of x plus x times the derivative of whole. The derivative of ln of x is 1 over ln of x times the derivative of ln of x, yung inside is 1 over x times the derivative of x is 1. And then, simplify 1 over x times y prime is equals to y prime over y, and right side, 1 times ln of x is equals to ln of x plus x times 1 over ln of x times 1 over x times 1. We can see here na meron tayong denominator na x and meron tayong x dito sa kabila. We can cancel out these two x's, and then matitira na lang is 1 over ln of x. And then the equation will now become y prime over y is equals to ln of x plus 1 over ln of x. And then we can now multiply both sides by y para makancel yung denominator y sa left side, and matira na lang is y prime. Now, the equation will become y prime is equals to y times quantity ln of x plus 1 over ln of x. And then, substituting the value of y, the final answer will become y prime is equals to ln of x raised to x times ln of x plus 1 over ln of x.